We are going to take irrational number. Now, when we have started the discussion of terminating decimal number, non-terminating decimal number, that day only we have discussed what is irrational number. The numbers which are non-terminating, non-recurring, the numbers which are non-terminating and non-recurring, those numbers are called irrational number. And the example of irrational numbers are root 2, root 3, root 5. These are the irrational number. When we will try finding the square root of this number, which is not a perfect square, when we will find the square root by long division method, we will be getting decimal number which will be non-terminating, non-recurring. Apart from these numbers which are not a perfect square and sitting inside the square root, we have also discussed that pi is also an irrational number. However, we take pi as a 22/7, but 22/7 is just the approximate value we take for doing the calculation in any of the question, but pi is not equals to 22/7. Pi is approximately equal to 22/7, not accurately exactly equal. Okay. So today we will be covering how to plot the irrational number, like how to locate the irrational number on number line. We have already discussed how to locate the rational numbers on number line. When we were having rational number, let's say we were having 5/2. How to locate it on real line? So what we used to do, we used to draw or recall the concept. The previous rational number was there in the previous class. So from there, what we were doing, we used to convert it in mixed fraction. When we will convert it in mixed fraction, we will be getting 2 times 4, 1, remainder is 1. So it can be written as 2 1/2, right? 5/2 can be written as 2 1/2, right? And if we have to represent it on real line, here is 0, here is 1, here is 2, and here is 3, here is 4. Okay, so 2 1/2 will lie in between 2 and 3. Okay, 2 is there and then 1 half extra is there. Okay, so it will lie in between 2 and 3. And what we used to do, how many part we have to cut? Yes, Shamya and Sat, do you know how to locate it? Shamya?
Ma'am, first we have to make it an improper fraction.
Mixed fraction?
Yes, ma'am.
Okay, we are having improper fraction.
Yes.
That we used to convert it in mixed fraction. Then we used to get the idea where exactly it will lie. It will lie in between 2 and 3. Then how many part we need to cut this 2 and 3?
Ma'am,
2 parts. So for cutting it 2 and 3 in 2 part, we have to draw one line. Okay, you can see one of the part is this one, another part is this one. 2 part only we have to make. So one line if I have drawn, that is enough. Now this one line here, this will be 2.5. Yes or no?
yes, ma'am.
Yes, Saad, are you getting it? This is how we used to represent rational number on number line, on the real line, right? Today we will be discussing how to locate irrational numbers on real line. So let's say we have to locate square root of 2. Okay, let's say we have to, the first question is locate square root of 2 on the number line. Now, as we know that square root of 2 is a non-terminating, non-recurring decimal number. So in between 1 and 2 there are infinite numbers. In between 2 and 3 there are infinite numbers. In between 3 and 4 there are infinite decimal numbers. Okay. So root 2, where exactly it will lie? To do that, first thing first, we need to know the Pythagoras theorem. Do you know what is Pythagoras theorem? Yes, Sam and Shadia. Sorry. Again, Samya and Sad. Really sorry. Yes, Shad, Shamya. What is Pythagoras theorem? Whenever we are having a right
Ma'am,
angle
a
triangle.
square plus b square is equal to c square.
Exactly. Yes, Shad, whenever we are having a right angle triangle, let's say we are having a right angle triangle ABC. Okay, here this AC is called the hypotenuse, opposite to 90 degree. Whatever side is there, that's called hypotenuse. And in this right angle triangle, hypotenuse is the largest side. Okay, hypotenuse is the largest side. How many sides we are having in this triangle? AB is one of the side, BC is the another side, AC is the third side. So this AC, which is opposite to 90 degree angle, that's the name of this side is hypotenuse, and this hypotenuse is the largest side among these three sides. And there is a rule given by the mathematician Pythagoras, who says that this hypotenuse AC square is equals to AB square plus BC square. Okay, this is the theorem, the rule given by the mathematician Pythagoras. That's why we call it Pythagoras theorem. So it says that hypotenuse square is equals to, in any right angle triangle, we are not talking about other triangle, right angle triangle, hypotenuse square is equals to perpendicular square plus base square. Plus base square. Okay, this is what the theorem says. We are going to use this theorem, the Pythagoras theorem, to plot this root 2. So what we are going to do, we are going to take one of the side as a 1. Okay, 1 unit. This side AB we are going to take as a 1 unit. This side BC also we are going to take 1 unit. Then automatically AC will come out as, can you tell me what will be AC? Shad and Shamya.
Ma'am, 1. Ma'am, 2.
Only 2, Shamya.
Ma'am, 2 square.
Okay, what is the formula? Formula is AC square is equals to AB square plus BC square. Yes, Shad, I have taken a right angle triangle ABC where
Okay, ma'am.
B is of 90 degree. Okay, and
Okay.
I have taken side AB as a 1 unit, side BC as a 1 unit. 1 unit means you can say it's 1 centimeter, 1 centimeter. Okay. Now we want to calculate the side AC by using Pythagoras theorem. So what does the Pythagoras theorem says? The Pythagoras theorem says that AC square is equals to AB square plus BC square. AC square is equals to AB square plus BC square. What is AB square? AB I have taken as a 1 centimeter square, so it is 1
square.
square. BC is 1 square.
1
So
square.
AC square, 1 square plus 1 square became 2. Can you tell me what is
2.
AC? What is AC? AC square is 2.
AC is equal to root 2. AC is equal to root 2.
Root 2. Right, Shamya? AC is root 2.
Yes, ma'am.
Okay, so this is how we will be able to get root 2, because we are not sure what is the value of root 2. Even if we will get the value of root 2 by long division method, maybe the approximate value, we will not be able to locate it on the real line. Okay, because it's non-terminating decimal number 1.41. What after that, infinite digits will keep on coming, keep on coming, keep on coming, non-terminating. That means it will never stop. So accurately we will not be able to locate that. Okay, so there is a trick to locate it. What is that trick? What we will do on the real line, on the real line, here is 0, here is 1. So we are saying that let's take from 0 to 1, let's take it as a base. Okay, here we are going to make a triangle. The same triangle where we have used the Pythagoras theorem, the same thing we are going to do on the real line. Okay, so we are going to take from 0 to 1, because we have realized that to get root 2, to get AC as a root 2, we need AB and BC, this two side 1 unit. This two side AB has to be 1 unit, BC has to be 1 unit. So here we are going and we are saying that one of the side we have taken 1 unit on the real line. That was very simple. From 0 to 1, definitely it's 1 unit. Okay, on 1 we will, by using, we will use a scale, we will use a scale and we will draw 1 centimeter perpendicular. Okay, by using a scale, a perpendicular, how much? 1 centimeter only. Okay, let's say this is point, you can say O, this is A, this is B. Now just join O and B. What we have done, listen to me carefully. 0, from 0 to 1 we have taken, we are sure that is 1 unit. Wherever 1 is there, there we are just making a perpendicular line, a straight line. By using a scale we can draw. Okay, scale, by using a scale we are dropping a perpendicular, a straight line that is of 1 unit. Okay, now we will just join O and B. We will just join O and B and we will say that OB is of root 2 unit. Yes or no? OB will be of root 2 unit.
Yes, ma'am.
Yes or no? Samya and Saad.
Yes, ma'am. Yes, ma'am.
Right? Right,
Yes.
Samya?
Yes, ma'am.
So OB will be of root 2 unit. Now, whatever is the length of this side OB, whatever is the length of this side OB, just take that length in your compass. Take that length, just just keep the needle of the compass on point O, just press the needle of the compass on point O and measure OB. Okay, measure OB. Once you will be able to measure this OB, that is root 2, exactly root 2. Previously we were not aware that how much is root 2. It is 1.4 and then infinite numbers are there. Now in our compass, exactly root 2 we are having. Okay, after taking root 2 in the compass, what we are going to do, we are going to keep the compass, the needle at the same place on 0. We are going to keep the needle at the same place on 0, at the same place 0, and then we have to make an arc like this. Arc will be of the length OB which you have taken root 2 length, that you are going to make an arc from 0. This total length will be root 2. Are you getting my point?
Yes, ma'am.
And this is how
Yes, ma'am.
accurately we will be able to locate root 2, which was not at all possible without doing this trick, without using this Pythagoras theorem. It was not possible because that is non-terminating, non-recurring decimal number. So exactly accurately we will not be able to locate it. Approximately we could have done, but appropriately exact point we would not have searched, like what will be the exact location of that. So by using the this hypotenuse, the Pythagoras theorem, This became simple. Again, I would repeat what we have done from 0 to 1. We have maintained, we know that is 1 unit, so we have kept it 1 unit. Then on 1, we have dropped a perpendicular, a straight line we have dropped. The straight line has to be of 1 unit only. Why 1 unit we are keeping? Because before that we have realized that to get the hypotenuse of root 2 unit, the rest of the two sides has to be 1 unit. Okay, so we have already realized that. That's what we are going to do here. 0 to A, 1 unit, and then A to B, 1 unit we are maintaining, and then we are joining this O to B. This OB, directly we can say it will be of root 2 because already we have done the calculation and we have checked it. So OB is of root 2. This much length, OB length we are taking in our compass, and we can make the arc from 0. That way exactly we are able to say this is the location of root 2. Is it clear to both of you?
Yes, ma'am.
Now root
Yes.
2 is clear. What about root 3, root 4, root 5? Root 4 we will be able to take it out. Root 4 means 2. That we will be able to locate. That is very simple. Root 9 is 3. That we will be able to locate. But what about root 3? What about root 5? What about root 6? Let's locate these numbers as well. Locate. Today we are not activating the assessment. We need one more class on this, and in the next class you can give the assessment, okay, which is based on irrational numbers. Okay,
Okay, ma'am.
so the next part is locate root 3 on number line. So to locate this root 3 on the number line, first thing first, we need to understand what is that. What is that? Again, we will take a triangle A, B, C, and this time our hypotenuse has to be of root 3. Has to be of root 3. So AB and BC, what we will take? See carefully. See carefully. If we will take AB, if we will take, let's say, AB as a 1 unit and BC as root 2 unit, then what will be AC? AC square is equals to AB square plus BC square. AB square is 1 square plus BC square is root 2 square. Can you please tell me what are you getting as a AC? Only AC. Samya and Shad. What are you getting as a AC? Yes. Shamya and Saad, what are you getting as a AC? 1 square is 1.
Ma'am,
Root
16.
2 square is what? Yes, sir.
Ma'am, 16. Ma'am, 16.
60 you are saying?
Ma'am, 16. 1 6.
16.
16.
16 you are saying. Yes, Samya.
Ma'am, 4.
4.
Yes,
Okay,
ma'am.
you said 4. Let's check it. Let's check it. So 1 square is 1. Root 2 square is what? Root 2 square when we will do, root 2 into root 2 when we will do, both the 2 will come inside one square root sign. It will make a pair and then 1 2 will come out. So only 2 is the answer. When we will do square of root 2, we will get only 2. When we will get square of root 3, they both will collaborate with each other. They both will just collaborate and will come inside one root sign because there is multiplication. And once they will come inside one square root sign, we know for a pair we can take out a number. So only 3 will be the answer. So be careful whenever we are having root 5 square, it will be only 5. Whenever we are having root 3 square, it will be only 3. Whenever we are having root 2 square, it will be only 2. Are you getting it?
Yes, ma'am.
Okay, ma'am. Yes, ma'am.
This any number inside the square root, if we will do square of that, square means what? Multiplication of the same number 2 times. Since there is a multiplication, both the numbers will come inside one square root sign and then we'll get the pair. Okay, so here what we will be having, 1 plus 2, only 2. 1 plus 2 is, AC square is 3. AC square is only 3. What is AC?
Okay. Root 3. Ma'am, root
Root
3.
3.
Root
AC is root 3. So to plot root 3, we need what we need? We need on one of the side, we need 1 unit, 1 centimeter or 1 unit, whatever you say. On the other side, we need root 2 unit. Are you getting it? To plot root 3, to get root 3, just like the
Yes, ma'am.
previous case, we need 1 centimeter on one side and root 2 centimeter on the other side. Are you getting it?
Yes, ma'am.
Yes, ma'am.
But now only we have discussed that it is not possible to get root 2. By using your scale, you will not be able to locate root 2. Only this Pythagoras theorem we can use to locate root 2. So to locate root 3, at first we need to locate root 2. Are you getting my point?
Yes, ma'am.
Yes,
When
ma'am.
you have to locate root 3, even if the question says to locate root 3, at first you have to locate root 2, because for getting root 3 we need root 2. 1 unit, 1 centimeter we will be able to plot by using the scale 1 centimeter from the centimeter scale. Okay, but how we will get root 2 centimeter? That we have to do at first. So if we have to locate root 3, just see the process carefully. A number line, a number line. Here is 0, here is 1, here is 2, here is 3, just like that. At first we have to locate root 2. Okay, so how we were locating root 2? 0 to 1, and then on 1 we used to drop a perpendicular which is of 1 centimeter, and then we used to join it to get root 2, to get root 2, right? This is how we got root 2. Now we have to locate root 3. So on this diagram only we will be able to locate root 3. For locating root 3, what we need? In our triangle, we need one of the side as a root 2, another side as a 1. This will give root 3 as a hypotenuse. So what we are going to do? Now we are having O, A, B. Now we are having OB as a base. Just see OB as a base. Look at it like this. This is how we are having OB as a base, which is of root 2. Here we will drop a perpendicular. A perpendicular we will drop, which is of 1 centimeter. And then we know when we will join it, we will get a hypotenuse, and that hypotenuse has to be root 3. Yes or no?
Yes, ma'am.
So this is
Yes,
how
ma'am.
a tilted triangle, the inclined triangle we have to draw here. But no worries, our concept has to be clear why we are doing this inclined triangle, just because of root 2. Okay, so we are having the side OB, which is of root 2. Now let's say this is the base. Let's say this base used to be straight. Now our base is like tilted. No worries. Here on the base we will drop a perpendicular. On the straight base, what we draw? A perpendicular like this. When the base is tilted like this, we will be drawing a perpendicular like this. That's it. Okay, so here we will be drawing a perpendicular which is of 1 centimeter. Okay, a perpendicular we will draw. A perpendicular we will draw which is of 1 centimeter. Perpendicular. Okay, like this. This is of 1 centimeter. Now when we will join it, when we will join this, let's say this point is C. So when we will join this O with C, we know this is of root 3 unit, because in our triangle we have seen, when the base is root 2, when the perpendicular is 1, then the hypotenuse has to be root 3 by using the Pythagoras theorem. Are you getting my point?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Okay, either you can do like this, or if you want a fresh diagram, then please do it like this. First, locate root 2 like this, the way we have located root 2 over here. Okay, locate it like this. Take it in a compass, root 2 measurement. Take it in a compass, root 2, and on the real line this is 0, this is 1, and on with the help of the compass you have taken the measurement of root 2. You are saying this is the location of root 2. Okay, on this location you have to drop a perpendicular. On this location, on this yellow dot, you have to drop a perpendicular that is of 1 centimeter. So here only you will draw a perpendicular that is of 1 centimeter. Now when you will join it with this O point, this is root 3. So to plot root 3, first you have to make this diagram, then you have to make this diagram, and then you are getting root 3. That you can take it in your compass, and again you can make the arc over it. That is exactly the location of root 3. Either you can do this complete process, the first one locating root 2 at first, taking root 2 measurement in the compass, and then just making root 2 from 0, and then just following the same step. On root 2 you have to drop a 1 centimeter perpendicular, then you have to just join to get the hypotenuse, which has to be root 3. Okay, either you do like this or you do like this process directly, which we have done, this one. Here only we have drawn root 2. Here only on the same diagram we are trying to plot root 3. Is it clear so far?
Yes, ma'am.
Okay, now if you
Yes, ma'am.
have to plot root 4, that is very simple. That means 2. You just have to locate 2. We know this is the location of 2. This is the location of root 4. This is the location of 2. Right? When you have to plot root 5, then what you will do? See, let's see in our rough diagram how we will be getting root 5. We need root 5 over here. Okay? We need root 5 over here. So what can be done? Any idea? Yes, Shamia and Saad. What can be the base and height? A, B, C.
Ma'am, we will have to start from 2.
Ma'am, root 2 and root 3.
If we will be taking root 2, if we will be taking root 3, Shad, let's take and check. Root 3
Okay, ma'am.
whole square plus root 2 whole square, that is 3 plus 2, that is 5. Yes, this can be one of the way, but getting root 3, root 2 is again difficult. Can we take 1 unit and 2 unit, or maybe root 4 unit? Can we? 1 square plus root 4 square, that means 1 plus 4, that means 5. Root 4 is what? 2. So this will be simple. Are you getting it, Saad? So if we have to locate,
Okay, ma'am. Yes, ma'am.
root 5, we can go this way also. We can take one of the side as a 2 unit, another side as a 1 unit. Then the Pythagoras theorem is what?
Yes, ma'am.
2 square plus 1 square is equals to 4 plus 1 is equals to 5. This is AC square. This is AC square. This is AC square, and AC is
Okay,
root
ma'am.
5. So this one is comparatively easier than this one, right? By following your
Okay,
way,
ma'am.
Shad,
Yes, ma'am.
yes, we are going to get root 5. That is perfect. But again, getting exactly root 3 in the compass, root 2 in the compass, this is quite like we have to again start from the very beginning. What is root 2?
Okay,
What is
ma'am.
root 3? We have to mark it, we have to plot it. But if we will follow this process, this is quite simple, right? So if we have to locate root
Okay,
5,
ma'am.
what we can do? Number line 0. We need one of the side. Realize it. Just see the picture carefully. One of the side as a 2, another side as a 1. So 2, getting 2 is very simple. On the real line, this whole number 1, 2, 3, 4, 5 is this type of integers. If we wanna get, this one is very simple. This is 2. Here we will drop a perpendicular of 1 centimeter, and then whatever we will join, that will be root 5. Can we say yes or no?
Yes, ma'am.
Yes, ma'am.
Is it clear to both of you?
Yes, ma'am.
Just a second. And if the question, like this type of question, however, will not come in exam, but if this type of classroom activity is there, where you have to represent square root of all the numbers, like root 2, root 3, root 4, root 5, all the number, root 6, root 7, on the same diagram, then see what you will do. This is just a activity, okay? If you have to do, this is how you can proceed. 0 to 1. First, root 2 we will be locating. How we were locating root 2? 0 to 1. This is 1 unit. On 1 we used to drop a perpendicular. This is also 1 unit. Okay, 1 centimeter rather you can say, because you are using centimeter scale. If we will join them, this is root 2. We are done with root 2. Here only we have discussed already. Here in this diagram only we can make root 3 also. Okay, so here we will be dropping a perpendicular of 1 centimeter, and if we will join like this will be of root 3, right? Shamia and Saad,
Yes, ma'am.
we are done with root 3.
Yes, ma'am.
Root 4 we have to do. locate. Here only we can locate root 4, because if the instruction is locate all this square root number in like one, by using one diagram only, that is called a circle type of diagram you will be getting. Okay, so let's locate. Here again we will be dropping a perpendicular. Again we will draw a perpendicular like this. Okay, a perpendicular like this which is of 1 unit. You check it. If one of the side is root 3 unit, another side is 1 unit, can you please tell me what will be the hypotenuse? AC. What will be AC?
Ma'am, 4.
Ma'am, 4.
Only AC is only 4 or root 4?
Ma'am, root 4.
Root 4, right? So we can say that once
ma'am.
we will join it, because this is 90 degree we have drawn. Okay, this is 90 degree we have drawn. Here we have drawn 90 degree. So when we will join it with O, we will be getting root 4. Now in the same continuation, again we will be dropping a perpendicular over here. Are you getting my point? Which is of 1 unit,
Yes,
1
ma'am.
centimeter. And when we will join it with O, we will be getting root 5. Getting it?
Yes,
Shamya?
ma'am.
Shad?
Yes, ma'am.
So in the same
Yes,
diagram, a
ma'am.
circle type of diagram you will start getting. Okay, root 4 we have done, root 5 we have done. Here only again 1 centimeter perpendicular you will draw, and you will join with O, you will be getting root 6. Okay, again root 6 plus 1 will give root 7. So a circle type of diagram you will start getting. This is just a classroom activity. If you are getting, this is how you have to do it. Okay.
Okay, ma'am.
Now to plot, we have
Okay,
realized
ma'am.
one thing, that to plot root 3, we need root 2. We need the location of root 2 to plot root 3. To plot root 5, we don't, even if we don't need this 2, we can plot root 5 by taking root 4, that means 2 and 1. Okay, what about root 6? To plot root 6, definitely we need this root 5. Okay, we need this root 5 and 1. Any other possibility for root 6? Any other possibility to plot root 6? Samya and Sad, think about it.
Ma'am, root 3 and root 3.
Root 3 and
Yes, ma'am.
Root
root
3.
3.
Yes,
Is
ma'am.
it so?
Yes, ma'am.
Yeah, this is also one of
Yes,
the
ma'am.
possibility of plotting root 6. If we will do root 3 square, only 3. If we will do root 3 square, again only 3. That means 3 plus 3, 6, and root 6 we will be getting. So yes, this is also one of the way. So can you see now you have already, you are getting how to plot this type of irrational number, how to locate it on the number line. If you have understood this
Yes, ma'am.
Pythagoras theorem, if you have understood the fundamental, then you will be able to do by yourself. Okay.
Okay, ma'am.
How to get root 3 and root 3? First you plot root 3. First you plot root 3. 0 is there, 1 is there. To get root 3, you know you have to get root 2 also. So 1, this is your root 2, and 1, this is your root 3. You got root 3. You need one more side, that is of root 3 only. Then only you will be able to plot root 6. So let me help you. Just draw a bigger line. A bigger line. Okay. And just measure this root 3 measurement in your compass. Measure it. What is the length of this side, which is of root 3 unit? That much you have to make an arc over here by placing the needle of the compass on this point. Are you getting me? The way we used to draw 1 centimeter over there, now we are drawing by pressing the needle of the compass. We are making root 3 unit over there. Getting it?
Yes, ma'am.
Now when you will join
Yes,
this
ma'am.
2, you will get root 6. So if the fundamental is clear, if the logic is clear, you will be able to locate this type of irrational numbers on the number line.
Okay, ma'am.
So this was one of the main concept which is there in irrational number. Now just a second, let me check what else we need to discuss here. Every irrational number is a real number. Is it true? Is it true? All the irrational numbers are real number. Let me write it. Every irrational number is real number. Is it so? Yes or no?
No, ma'am.
Yes, Shad? No, it is false, right? Or is true? Yes, Shad? Yes, Samya. Real number means what? Real number means all the number which exist in this universe, Samya. So real number means rational number also. Real number means irrational number also. So all the rational number, irrational number, natural number, whole number, uh, like integers, whatever number exists in this universe, in this real world, those are called real number. Please don't just get confused with the name. This is how the diagram is. Previous day also we were discussing about the diagram, that first natural number is there, which is 1 2 3 4, all the counting number. Now whole number is there, which is 1 2 3 4, all the counting number, but 0 is also there. So 0 1 2 3 4, these are whole numbers. Okay, after that we are having integers, we represent it with z. That means whole number is also integer, natural number is also integer, but few more extra numbers are there, those are negative number, that is -1, -2, -3, 0 1 2 3 4, these are integers. Okay, now what is rational number? We represent it with q. What is rational number? Rational numbers are integers, rational numbers are all the whole numbers, rational numbers are all the natural numbers, rational numbers are all the fractional number which is in the form of p by q. Apart from integer, whole number and natural number, it is also rational numbers are also the number which is in the form of p by q, maybe 2 by 5, maybe 1 by 2, maybe 3 by 5. Okay, so this type of decimal number is also rational number. Now what is irrational number? Irrational number are the number, irrational numbers are the numbers which are not rational. That means example √2, √3, √5, pi. These are the example. Now everything comes, this everything comes inside real world, that is real number. Are you getting my point?
Yes, ma'am.
So see the statement, every irrational number is a real number. Yes. Yes, every irrational number, every rational number, everything comes in this real world, real number. Got it?
Yes, ma'am.
So don't get confused with the name. It's just real number. That means all the number exist in this universe are real number, which we can write it on the notebook, which we can see anywhere as a data, like anything which we can write a number, that those are real number only, be it a decimal number, be it a terminating decimal, be it a non-terminating decimal, be it a recurring, non-recurring, doesn't matter, everything is real number. If I am talking about a number 2 3 4, any number which can be written on this screen on your paper, that is real number. Okay,
Okay, ma'am.
now the next statement is every point on the number line is of the form root m, where m is a natural number. Think about it. Every point.
Ma'am, false.
Okay. It is false. Yes, Shad, is it false? What is the example? Like any number which every point on the number line is of the form root m, where m is a natural number. Is it so? So a number line, on the number line, we are having all the real numbers. Real numbers. Maybe you have seen only integers, that is 0 here, positive 1, positive 2 there, negative 1, negative 2. But let me tell you, this is a real line. We don't write all the numbers always. We usually represent the integers, but rational number, irrational number, real number, like it is a real line. From minus infinity to plus infinity, all the numbers are sitting on this line. That's called real number line. Okay, real line, we call it also real line. Maybe previously when you were not aware with this real numbers, then we were only taking 0, 1, 2, 3. We only take these numbers. Just a second. -2, -3, just like this. These are integers we only represent over here. But be careful, in between all the integers, there are infinite decimal numbers which is sitting over here. Okay, basically it's not an integer line, this is a real line where all the real numbers are located. Okay, now
Okay.
the statement says every point on the number line. That means every point on the number line, every point in between this thousand infinite points are there, infinite points are there, in between this infinite points are there. So it is saying every point, that means all the real numbers, okay, is of the form root m. All the real numbers is of the form root m. Is it so? Where m is a natural number, the natural number is 1, natural number is 2, natural number is 3, natural number is 4, natural number is 5, natural number is 6, natural number is 7, natural number is 8. So is it so that if we will take natural number for m, it will give all the real numbers? No. Okay. Yes, Samya, you said it correctly. If we will take natural number only, we will get a lot of points over here, which will be there on the number line, but not here. We are having infinite points. This root 1 is only 1. Here is the point. Root 2, now only we have seen that root 2 we were getting in between 1 and 2. Okay, 1.4 something was the value, accurate value we don't know, but we got the location of root 2. This is the location of root 2. Root 3, we realize the location of root 3 is again in between. If you will just measure it with the help of compass and will make the arc from 0, you will get root 3 will also lie here. You will get root 3 also lie here. Okay, what about root 4? Root 4 is nothing but 2. So this is the location of 2. So are we getting all the point? Can you see we are not getting all the point? Infinite points are there and we are not getting all the point. By taking this root m, we are not able to touch this sky points. Can you see infinite numbers of sky points are there? And
Yes.
we are not getting these points by just taking root m, where m is a natural number. Are you getting it?
Yes, ma'am.
So yes, it is false.
Yes, ma'am.
Next is, every real number is an irrational number. Let me know. Every real number, every
Ma'am,
real,
false.
yes, Tamia, you said it
Ma'am, false.
exactly. Every real number is an irrational number. Yes, Saad, is it true or false?
Ma'am, false.
It is false, because real number means what? Let's get back to our picture. Real number means rational number, integer, whole number, natural number, and here here at the corner irrational number is also sitting. Okay, so real number means everything. Only irrational number we cannot say it's real number. Every real number is an irrational, no. Okay? Real number, it can be rational, real number can be integer, real number can be whole number, real number can be natural number, real number can be irrational number. But all the real number are irrational? No. All the irrational numbers are real numbers. Okay.